Hi all, I am Ramya. I am a faculty in Pendab Academy and I am dealing with chemistry. So for many occasions, we used to we used to decorate our rooms, right? We used to decorate our home, we used to decorate our room, etc. So what are the things that we are using common that we are commonly using for decoration purpose? We are using balloons, we are using colored ribbons, we may be using colored papers and so on. So I am going to take or I am going to choose this balloon for decorating my home. I have taken two balloons that I have blowed that two balloons and I have made into different shape. Suppose I have taken two balloons and tied it together. Which shape will be, what will be the shape of that? It will be somewhat like V shape, right? I am taking two balloons and I am blowing it and I am tying together. It may be like this shape, okay? Maybe like V shape or so. Again I have taken three balloons and I am tying it together. I am taking three balloons and I am tying it together like this. It may be in this shape, somewhat like a triangular shape. Suppose I am taking four balloons and I am tying together, it will be somewhat like this shape. It is somewhat like this shape. It is tetrahedral. So, when we are blowing these balloons and tying together, we can make into different shapes, right? In a similar manner, when we are talking about atoms or when we are talking about molecules, we can say atoms combine together to form different types of compounds. Elements combine together to form different types of compound. While they are forming these compounds, they are having definite shape. So we can now study about the shape of molecules. So we can study about the shape of molecule. So many scientists came forward with different theories to study about the shape of the molecule. And one of such theory is the valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. So we can say it as VSEPR theory. So I said when we are blowing these balloons and tying together, it is forming into different shapes. Likewise, these molecules also, atoms also combine together to form different molecule and they'll be doing so in a particular geometry or in a particular shape. So according to valence shell electron pair repulsion theory, as the name suggests, the theory merely depends upon the valence shell electron pairs. Means the theory depends upon the electron pairs in the valence shell. Now we can see what are the postulates of this VSEPR theory. What are the postulates of this VSEPR theory? According to VSEPR theory, it says that the shape of molecule depends upon the number of valence shell electron pair. According to this theory, shape of molecule depends upon the electron pairs in its valence shell. There are two types of electron pairs. One is the electron pair that is formed into that has been combined with any other elements or that has been bonded to other element. Such electron pairs are known as bond pairs. Also there are certain electron pairs that has not participated in bond formation and such electron pairs are known as lone pairs. So we can say in the valence shell of an atom, in the outermost shell of an atom, there are two types of electron pair. The first pair is bond pair that has been bonded with the electron pairs that has been bonded with some other atoms, and the other one is the lone pair that has not undergone undergone any bond formation. So there are two types of electron pairs, bond pairs and lone pairs. So according to Vsepr theory, the electron pairs will be arranged in such a way that the repulsion is minimum. According to Vsepr theory, we can say the electron pairs are arranged in such a way that the repulsion is minimum. Electron pairs are arranged in such a way that the repulsion is minimum. Okay, so since there are two types of electron pairs, we can say the repulsion will be the magnitude of repulsion will be greater for lone pair. Lone pair repulsion will be maximum. Repulsion between two lone pair will be maximum. Then lone pair and bond pair. Then bond pair. Whatever it is, the molecule will be opting such shape in which the repulsion is minimum, or molecule will be preferring that geometry in which there will be less repulsion between these electron pairs. So this is the basic of Vsepr theory. So in order to minimize repulsion, these bond pairs will be elongated in such a way that the repulsion is minimum. Okay, suppose we can explain it using an example. Consider water molecule. H2O. Here oxygen is the central atom. What is the atomic number of oxygen? Atomic number of oxygen is 8. 2, 6 is its electronic configuration. Atomic number of oxygen is 8 and 2, 6 is its shell-wise electronic configuration. So in order to complete its octet, it undergo bonding with two hydrogen atoms. This 1, 2, 3, 4, 5 and 6. This undergo bonding with hydrogen atom. Again, another hydrogen atom is here. So there is a total of 8 electrons around this oxygen atom and a total of 2 electrons around this hydrogen atom, and it is stable. Okay. Now consider this oxygen atom. This is one bond pair. This is another bond pair. So how many bond pairs are there? There is 2 bond pair. Okay. One electron from oxygen, another electron from hydrogen. This constitute one bond pair, and one electron from this oxygen atom and one electron from this another hydrogen atom constitute another bond pair. So altogether there are 2 bond pairs. And look, there are 4 electrons which has not undergone bonding with any other atom, or these are lone pairs. So how many lone pairs are there? 2 lone pairs. This constitute one lone pair and this constitute another lone pair. Okay. So this is one lone pair and this is another lone pair. So what will be the preferred geometry of this molecule? These 2 bond pairs and 2 lone pairs. Altogether there are 4 electron pairs. So these 4 electron pairs are arranged on the 4 corners of a regular tetrahedron. So what is the tetrahedral shape? A triangular shape like this. This is the tetrahedral shape. Look, these are the 4 corners. So the electron pairs will be arranged in such a way that these electron pairs occupy the corners of the regular tetrahedron. So 2 corner will be occupied with bone pair electron and the other 2 corner will be occupied with lone pair electrons. So if this corner is occupied with bone pair electron, this corner will be occupied with bone pair electron, and the other 2 corners of the tetrahedron will be occupied with lone pair electron. So this is the geometry of the molecule. Okay, the geometry of 4 electron pair is tetrahedron. Okay, while talking about the shape of water molecule, we can only consider the bone pairs present here. Okay, while talking about the shape of water molecule, we can only consider the bone pair of electrons present there. So the 2 bone pair electron here constitute one from here will be in a, what will be the shape of this? There are the 2 bone pairs are present here, and what is the shape of this? It will be in V shape or bend shape. So what is the shape of water molecule? It is V shape or bend shape. What is the shape of water molecule? It is V shaped, or the shape of water molecule is bent. Okay. So I think it is clear. In water molecule, oxygen is the central atom. There are 2 bond pairs and 2 lone pair. These 4 electron pairs are arranged in the 4 corners of a regular tetrahedron. 2 corners are occupied by this bone pair electron and the other 2 corners are occupied by lone pair electron. While talking about the shape of the molecule, even though the geometry is tetrahedron, while talking about the shape of the molecule, we can only consider the bone pairs present in this molecule. So these bone pairs are arranged in a V-shaped manner. So the shape of the molecule is V-shaped or bend shape. Okay, now consider another example. BF3, boron trifluoride, BF3. So here boron is the central atom. Okay, so boron, what is the atomic number of boron? 5. It is 5. 5 boron. Atomic number of boron is 5. So altogether 2, 3. It is the shell-wise electronic configuration of this boron. So now boron is the central atom. It is bonded. There are 5 electron pairs. 1, 3 electrons are there on the outermost shell of the atom. So according to Vsepr theory, we are considering only the valence shell electrons. Okay, we are only considering the valence shell electron pairs. So since there are 3 electrons on the valence shell of boron, we can draw these 3 electrons here. Right? Now, one electron is bonded with fluorine, another electron is bonded with other fluorine, and the next electron is bonded with the third fluorine atom. So altogether there are 3 bond pairs. Now how we can arrange this 3 bond pairs so that the repulsion between this bond pair is minimum? The only possible arrangement is this trigonal arrangement. Okay. If the electron pairs are at the corners of a regular triangle, then the repulsion will be minimum. Okay. So the shape of geometry, if there are 3 bond pair, the geometry is trigonal planar and the shape of the molecule is also trigonal planar. Okay. Shape of the molecule is trigonal planar. Now consider another example, that is ammonia. Consider another example, that is ammonia, NH3. In ammonia, nitrogen is the central atom. Okay. Nitrogen, atomic number of nitrogen is 7. That is 2, 5. Okay. So in the valence shell of nitrogen, there are 5 electrons. So we can draw this 5 electrons. 1, 2, 1, 2, 3, 4 and 5. Okay, so in the valence shell of nitrogen there are 5 electrons. We are drawing this 5 electrons here. One electron is bonded with hydrogen. Another electron is bonded with other hydrogen. And the third electron is bonded with the third hydrogen atom. Okay. So there are 3 bond pairs. 3 bond pairs are there. 3 bond pair of electrons are there. Okay. And there is one more electron pair here. And it is the lone pair of electron. So this is the lone pair of electron, which is one lone pair is also present here. So we know the 4 electron pairs can be arranged at the corners of a regular tetrahedron. As we said before, these 4 electron pairs are arranged in such a way that the repulsion is minimum. So the only possible geometry there is the regular tetrahedron. If it is regular tetrahedron, then only the repulsion between this electron pair will be minimum. Okay. So we can say if there is only 3 bond pair like that in BF3, the geometry of NH3 will be regular, geometry of NH3 will be trigonal planar. But due to the presence of one lone pair on this nitrogen atom, this lone pair bond pair, due to the lone pair bond pair repulsion, these bond pairs are shifted like this. So it is not the regular trigonal planar geometry. It is bend shaped molecule, or it is pyramidal structure. It is like a pyramid. Like, look, it is like a pyramid with 3 corners here and one lone pair at the top. It has pyramidal shape. So we can say ammonia has pyramidal shape. Number of bond pair is 3. Number of lone pair is 3. So once we know the number of electron pairs around the valence shell of an atom, we can predict the geometry of the molecule by considering this repulsion. Okay. We know the repulsion between lone pair is maximum. Then the repulsion between lone pair and bond pair comes, and the repulsion between bond pair is minimum. So molecule will be preferring that geometry in which the repulsion